We think the universe will always shine. Stars, galaxies, light everywhere. But scientists know something terrifying. There will be a time when the last star dies. No explosions. No warning. Just darkness. White dwarfs cool down. Red dwarfs burn out. Black holes slowly evaporate. Galaxies drift apart. Until nothing can be seen anymore. No light. No heat. No time as we know it. This is called the heat death of the universe. And once it begins, there is no way back. When we look at the night sky, it feels permanent. Stars seem eternal. Galaxies look frozen in time. But the universe is not static. It is changing very slowly, but constantly. Right now, the universe is about 13.8 billion years old. And it already carries the signs of its future. Not a violent end. Not a sudden catastrophe. But something much quieter. Every star you see exists for one simple reason. It burns fuel. Hydrogen turns into helium. Energy is released. Light travels across space. But fuel is finite. Massive stars burn fast and die young. Small stars burn slowly and can survive trillions of years. Yet none of them are immortal. Even now, fewer stars are being born than in the past. The peak of star formation happened billions of years ago. Since then, the universe has been slowly dimming. At the same time, space itself is expanding. Not stars flying away, but the fabric of the universe stretching. Distant galaxies move farther apart every second. Eventually, they cross a boundary where their light can no longer reach us. In the far future, observers inside a galaxy will see almost nothing. Other galaxies will disappear beyond the cosmic horizon. Not because they're gone, but because the universe has become too large. The night sky will look emptier than we can imagine. As time goes on, stars begin to disappear one by one. Large stars explode as supernovae. Smaller ones quietly fade into white dwarfs. White dwarfs don't shine on their own. They glow only because they are hot. But they cool. Trillions of years pass. White dwarfs lose their remaining heat. They become black dwarfs, dark, cold stellar remnants. By this point, the universe contains almost no visible light. The final sources of light are red dwarfs. They are small, dim, extremely efficient. Some red dwarfs can burn for 10 trillion years or more. But even they cannot escape the rules of physics. Eventually, nuclear reactions stop. The last star goes dark. There is no explosion. No moment anyone could witness. Light simply stops being produced. Without stars, the universe still contains matter. Planets, dead stars, black holes. But everything is cold. Temperatures approach absolute zero. Motion slows. Energy becomes evenly distributed. This state is known as heat death. Not death as an event, but death as a condition. Nothing happens anymore. For an unimaginably long time, black holes dominate the universe. They orbit. They merge. They quietly exist. But even black holes are not eternal. Through a process called Hawking radiation, they lose mass extremely slowly. A stellar black hole takes about 10 years to evaporate. Supermassive black holes take far longer. Eventually, the last black hole disappears. Not with violence, but with silence. After this point, the universe contains elementary particles, extremely low energy, vast, empty space, no stars, no galaxies, no structure. Time still exists, but nothing meaningful happens within it. The universe does not end. It simply continues, in a state where change is no longer possible. This is not a story about fear. It's a reminder of scale. Human history fits into a fraction of a second. On the universe's clock, everything we know exists during one brief, luminous era, the age of stars. We are alive during the brightest chapter the universe will ever have. The end of the universe will not be dramatic. There will be no sound. No collapse.
No final moment.
Just a gradual fading, until darkness becomes permanent, and the universe keeps going, long after there is anything left to see it.